In this video, we're going to be talking about cube roots and other various nth powered roots, so fourth roots and fifth roots, things like that. To start, let's talk about a cube root. So just like a square root is saying what times itself would give you the value under the radicand. A cube root is saying what times itself 3 times, or what cubed would give you that value underneath the radicand. Let's try some examples. The cube root of 0. What times itself 3 times would give you 0? The only possible value is 0. 0 times 0 times 0 is still 0. B. The cube root of -8. What times itself, it has to be the exact same value, times itself 3 times would give you -8. So I'm going to take a step to rewrite this. -2 times -2 times -2 would give you -8. 3 negatives will give you -8, right? So if I cube it and I take the cube root, I undo that cube, I'm going to end up with -2. Now you might be saying, wait a minute, hold on. You just said earlier that the square root of -3 squared was a +3 and not a -3. Okay, well, square roots and cube roots are different, right? So square roots, I'm saying times itself twice. And when I multiply 2 negatives, I get a positive. With cube roots, if I multiply 3 negatives, I get a negative. Okay, so the negatives work differently with the cube roots because I can multiply a negative 3 times and get a negative. Versus with squares, I cannot multiply something twice by itself and get a negative value. Alright, let's look at the next one. The cube root of the square root of, the cube root of 1 divided by 64. Sorry, there should not be a square root in there. So just like before, I could break this up into the cube root of 1 divided by the cube root of 64. So what times itself 3 times would give you 1? Just 1. 1 times 1 times 1 equals 1. Then I ask what times itself 3 times would give you 64. Well, if you're not sure, you could always factor it. 64 is 8 times 8, and 8 is 2 times 4, and 4 is 2 times 2. So what times itself 3 times would give us 64? Well, I have a set of 3 numbers here, and a set of 3 numbers here. So this is the same thing as the cube root of 2 cubed times 2 cubed, right? I have 2 cubed here and 2 cubed there. Multiply it all together, I should get 64. And the cube root of 2 cubed is just 2. And then I have another factor of the cube root of 2 cubed is just 2. Multiply those together, and I get 1/4. You don't necessarily have to write all of that out if you don't want to. You could have also noticed that if I had grouped them a little bit differently, so I have 6 2's here. I have 1, 2, 3 sets of 2 2's. So again, this is like 4 times 4 times 4. So the cube root of 64 is 4, because 4 times 4 times 4 gives you 64. Okay, so there's a couple different ways that you can look at that. You can look for groups of 3, and every group of 3 I can take the cube root of it. Or you could say, I just need 3 groups total. How do I split that up into only 3 groups? So 4 times 4 times 4 will give me 64. Okay. What if we throw in some variables? So now I'm taking the cube root and not the square root. So I'm asking what times itself 3 times would give me x to the 9th. So let's do our little experiment over here. X times x times x is x cubed. X squared times itself 3 times will give me 2, 4, 6. X cubed times itself 3 times would give me 3, 6, 9. X to the 9th power. Do we see a relationship between what is being cubed and the value that we end up with? So if I'm going to end up adding these exponents, I'm adding the same value 3 times. So if I'm starting with x to the 6th, and I want to know what times itself 3 times would give me that value, I can just divide by 3. 6 divided by 3 would be 2. 2 plus 2 plus 2 gives me 6. 9 divided by 3 is 3. 3 plus 3 plus 3 is 6. 12 divided by 3 is 4. 4 plus 4 plus 4 is 12. So again, if I'm doing the cube root, I just have to take that exponent and divide it by 3. And that's what times itself would give me that value. So again, I'm going to rewrite this just to show you. What times itself 3 times would give me x to the 9th? X cubed would give you that. Again, with that power rule, 3 times 3 is 9. So x cubed would give you x to the 9th. Now I'm cubing it. I'm taking the cube root of it. And I should just get x cubed. Sorry, that's a lot of cubes going on there. Alright, I have cubed it. I've uncubed it. I have just left what was underneath. Let's look at one more. I have the cube root of negative 64 x to the 6th. Well, we already factored 64 over here, and we know that 4 cubed gives us 64. So what times itself would give us a negative 64? Well, that'd be negative 4. Negative 4 times negative 4 times negative 4 is negative 64. And then for the cube root of x to the 6th, I take 6, divide it by 3, and get 2. X squared times itself 3 times would give me x to the 6th. And one more here. The cube root of negative 27 x to the 12th. So what times itself 3 times would give me negative 27? So again, if you're not sure, you could factor. This is 3 times 9. 9 is 3 times 3. So 3 cubed would give us 27. And in this case, a negative 3 cubed. Negative times negative times negative ends up negative 27. So I get negative 3 times itself. 3 times would give me negative 27. For x to the 12th, I take x to the 12th, divide by 3, and get x to the 4th. So x to the 4th times x to the 4th times x to the 4th would give me back where I started at x to the 12th. Undoing that cube. For other various roots, it's similar. So with this case, we were talking about cube roots. I needed something times itself 3 times. If I'm looking for a 4th root, I need something times itself 4 times. If I'm looking for a 5th root, I'm saying what times itself 5 times would give me that value underneath the radicand. Okay, so it's all about the root. That tells us how many times we're looking for something to be multiplied by itself. So 16, I want the 4th root of 16. So what times itself would give me 16? So, or times itself 4 times. I'm going to start by factoring. 16 is 4 times 4. 4 is 2 times 2. So this is the same thing as the 4th root of 2 to the 4th power. So I'm taking the 4th power, I'm taking the 4th root, I just get 2. Alright, Part B. This one says I want the fourth root of negative 16. So what times itself 4 times would give us negative 16? Well, a lot of times students say negative 2. But let's try it. Negative 2 to the 4th power, does that give me negative 16? So a negative times a negative times a negative times a negative. I have 4 negatives. That will actually end up positive 16. So that's not true. Don't do that. So this is the same thing as taking the square root of a negative number, taking the fourth root of a negative number. There's no real solution. And if we can think about this a little bit, when else would there be no real solution? So we said square root, we said a fourth root, we said a third root was okay because 3 negatives make a negative. What about fifth root? If I had 5 negatives, I could get a negative. What about sixth root? I'd have 6 negatives being multiplied together. That's going to make a positive. So I can't take the sixth root of a negative number. There's no real solution to that. Do we see a pattern? It should be any even root. 2, 4, 6, 8. I can't take the square root of a negative number. There's no real solution to it because if I have an even number of negatives, when they multiply together, they give a positive number. Okay. Alright, part C. Now be careful with this. This little number is the index. This is the fourth root. This bigger number is saying 5 times that square root. Okay, so it's on the outside of the square root. It is being multiplied by that square root. We do have to actually simplify the square root first, though. So, or not square root, fourth root, sorry. I need to simplify this fourth root first. I need to know what times itself 4 times would give me 625. So I'm going to go ahead and factor it. Do a little bit more side work down here. 625. Well, it ends in a 25, so I know 25 goes in. It's like quarters. There's going to be 4 quarters and $1, and there's $6 here. So 4 times 6 would be 24, plus 1 more would be 25. So 25 times 25 should give me 625. Then I can break down 25 into 5 times 5. And I see there are 4 5s. That is exactly what I needed. So what times itself 4 times would give you 625? 5. Now I'm going to put this in parentheses here because we still have that 5 being multiplied on the outside. The square root of the denominator, what times itself 4 times would give me 81? Well, 81 is 9 times 9. And 9 times 9 is 3 times 3. So what times itself 4 times would give me 81? 3. And then lastly, I do need to multiply by that 5 that was on the outside of the radical. So make it a fraction by putting it over 1. And I end up with 25 thirds. Alright, this next one here, I'm looking for the fifth root of negative 32. Now this is an odd root, so that negative is okay, because an odd number of negatives is a negative. And I need to factor 32 to figure out what times itself. So 32 is 8 times 4, 8 is 4 times 2, and 4 is 2 times 2. So I have 1, 2, 3, 4, 5 2's. So what times itself 5 times would give you 32? Negative 2, right? I need that negative 5 times to end up negative 32. Alright, let's look at a few more kind of unique examples. So now again, we're taking different roots other than a square root, and we're assuming all the variables represent non-negative real numbers. And we're just using that fact that, in general, a nth root and an nth power undo each other in that sense. So I have this quantity, x plus 6 to the 4th power, and I want to take the 4th root of it. So that 4th power and that 4th root are undoing each other, and I'm just left with x plus 6. Okay, part B, I have the cube root of -3 cubed. Now a cube root is a negative number, or an odd root, so negatives are okay. So I cube it, I take the cube root, and I should just get -3. Again, if I cube this -3, so -3 times -3 times -3, I get -27. So it's still going to be negative, okay? Versus if it was an even power, an even number of negatives would make that positive, and that would change my answer. It wouldn't just be -3, it'd change it to a positive. Alright, here I have the 5th root of 7x minus 1 to the 5th power. I have the 5th power, the 5th root, they undo each other, so now I'm just left with 7x minus 1. And this last one looks different. Okay, a lot of the times students try to take the square root of x squared and say, okay, that's going to be x, and square root of 9 is going to be 3. So it must be 3x or something like that. Well, not quite. What do we do when we're not sure what to do? What's that thing that I say? If you're not sure what to do, it doesn't hurt to factor. So I see x squared. This is a quadratic equation. It is not linear because of that x squared. Or not equation, expression, I should have said. So I need to factor this. I need to know what times itself would give me this entire quantity. Okay, not just pieces of it. What times itself would give me x squared plus 6x minus 9. So we factor. So x times x would give me x squared. And then I want to know what multiplies to a positive 9 but adds to a positive 6. Well, 3 times 3 would give me 9, and 3 plus 3 would give me 6. All the signs are positive, so these both end up positive. So that means the square root of x plus 3 squared, right? Quantity times itself is that quantity squared. So the square root of x plus 3 squared is just x plus 3. Alright, so again, when in doubt, factor.